the room. So I would strongly encourage you to meet as many people as you can tonight and really weave our community together. Okay. So I've got 3 asks. One is to be open to different perspectives. I really hope that you will have your concept of these topics stretched in different directions, and that's massively valuable in these rushing times where we're so busy and it's too hard to read everything on Facebook these days. So let's slow down and take the time to really appreciate a different perspective. Try and take a key learning away from tonight. So those the introverts in the room, take that opportunity right now to pause and reflect from time to time, and we'll be asking you to share in a safe way with the person next to you from time to time. So really capture some learnings as much as you can tonight. Feel free to take notes. Magazine connections, I already covered that. And yeah, and then just digital citizenship. Please be respectful and ethical. That's also a message to our rival, so I might touch on that in a second. Feels like a long time. Yeah. Oh, okay. Can I just say a quick hello, welcome? Can we do it together? Hi, everyone, welcome, and thank you for joining us for Tech Talk tonight. I'm sorry we couldn't get you in a little faster. We've got a whole audience here waiting to hear from 4 amazing speakers tonight, and we're so pleased that you could join us tonight. So all around the world, can we give a massive round of applause? Fantastic, yes. So we're being respectful and ethical. That was the part of the housekeeping I needed to get to. Social media these days create these open, messy forums where everyone's free to voice their opinions, but sometimes these can be harmful, and they do have effects offline as well as on. So just please be respectful in how you conduct yourself. And I think let's keep it friendly and thorough. Awesome. To my bit really quickly, I think we got some classic feedback last time that perhaps the moustache man spoke a bit too much. I'm looking at you. Somebody laughed at you. So this is our program for tonight. We're a little bit behind schedule, but I think we're tracking really well. We are going to have a wonderful welcoming speech from our hosts. We're going to run into our 4 amazing speakers with perhaps a little energy break in between. And then we're going to do our closing group photo, networking, we got more stuff, drinks and whatnot outside. Cool. And at that point, we'll be saying goodbye to our live audience at the end of the 4th speech there. So for tonight, just please note, we're going to try and limit Q&A, questions and answers to the end of our speakers' parts. We want to try and capture as much of their talk as possible before we pause for audience participation. So I'll remind you that later for that. And here we go. Right, so let's introduce myself. We've done the housekeeping, just a very quick introduction to Tech Talk and the team for Tech Talk. We've got the amazing Masood over here to give us a wave. Masood, can you give me a wave? So a little bit about us. Tech Talk is your professional network, bringing together technology practitioners, academics, and industry leaders. We'll probably add in their ecosystem builders, economic development partners, and that sort of thing. They always have a good presence, Callahan Innovation and the like. The world we believe in that doesn't exist yet is the one where skill shortage gaps have been filled. This is one of those sort of growing areas of concern for us as a society, as some of the privileged have access to these technologies, are able to move much faster than some of those who do not. And the pandemic has really shown up and flared up the pain of those gaps. So that's one of our big problems we're trying to solve in the world, is to create conversation spaces like this that shape what happens next, to give us a world where we don't need gaps. There might be something we talk about in the museums. Are you with me? Yeah. Are you with us? How are you? Awesome. Okay. And yeah, I think actually I'm very curious about why you've come along tonight. So I wonder if you could take an opportunity to turn around to somebody that you don't know. Hopefully you haven't interacted with them. Don't move from your seat, but maybe the row behind you or something like that. And have a quick pair share. Introduce yourself and why you came along tonight. Go. Yeah.
Let's go. Do you want the seat? Yeah, I imagine. It's stressful. You're nice, eh?
Well, actually, he thinks on Jennings needs a computer.
Okay, so just hit record once and then it'll record everything across all the speakers. Stop that the first speaker. Okay.
Yeah, of course.
Igor!
You're still thinking.
Nice. Can you give Igor a round of applause? That likely come out, didn't it? Cool. Thank you very much for that. Look, people from all over the world are engaged in this conversation. We've had, something like 1,200 participants in TechTalk. Can you believe that? Isn't that incredible? It's amazing, right? Now, the data that supports this comes from a lot of the surveys, the anonymous surveys that you've been filling in at previous events. So we'll have one for you at the end of this of tonight. We really want to encourage you to kind of get online when that time comes and give us some answers. It's all anonymized, but it helps us pull this sort of picture to reflect back to you for the conversation. So thank you. Cool. Yeah, I think we're ready. So, tonight, we are very privileged to have the Dean of Engineering and Professor of Electrical, Computer and Software Engineering for the University of Auckland, Professor Gerard Rowe. He's going to be welcoming us. Gerard's research interests lie in the areas of radio systems, electromagnetics, bio and electromagnetics, and engineering education. I'm so glad I did my tongue twisting but that's a lot of stuff. He has received numerous teaching awards, including a National Tertiary Teaching Excellence Award and an Australasian Association for Engineering Education Award for Excellence in Engineering Education. Please put your hands together for Professor
Tēnā koutou katoa, ngā mihi nui ki a koutou katoa, ko Gerard Rowe aha. It's my pleasure to welcome you here this evening, and on behalf of the Faculty of Engineering, it's fantastic to see you here. We have two competing events actually in the faculty this evening. We have a engineering information evening going on just over to my left, which is final year high school students and their parents who are also here to find out a little bit more about what engineers do and whether engineering is the right career for them. And I thought to sort of introduce the faculty, I might tell you a little bit about what we do here, how many students we have studying here, and therefore what the likely pipeline is for your future employees, for your businesses. So we're the largest and most highly ranked engineering faculty in the country. Encouragingly, despite COVID, we have our largest ever first year this year. We've got 1,050 students in first year engineering in semester one, and overall we've got 4,001 students in our BE Honours at present. Our cohort's about 26% women, around about 4% Māori and 4% Pacifica, and we have it's a 4-year degree. We have a common first year, so those 1,050 students will spend the first year being exposed to all of the different engineering disciplines that they might study in, and then at the end of that first year they make that very difficult choice as to which specialisation they'd actually like to continue in. We also use that first year to transition from high school to university, because the academic literacies that they need to develop at university to become independent, creative, innovative graduates, we need to move them on from those study skills that got them good grades at NCEA or at Cambridge or international or baccalaureate. And for that reason, we start our first year with our best teachers. So our cohort overall is 65% undergraduate, 24% postgraduate, but that includes the final year of the BE Honours. It's an honours degree, so the final fourth year is taught at postgraduate level. And we also have 11% of our cohort are research students. So roughly we've got a little over 500 master's students, that's taught and research masters. We've got currently about 520 PhD students, and there are a little over 50 students who are studying either postgraduate certificates or postgraduate diplomas. In terms of staffing, we're around about 270 staff in the faculty. There's a little over 140 academic staff and close to 130 professional staff in the Faculty of Engineering. Now, in the undergraduate program, we have 5 departments, and across those 5 departments, we have 10 specialisations taught. So in civil and environmental engineering, there are now 2 specialisations, civil engineering and structural engineering. Structural engineering is very new. The students who are studying in that specialisation are just in the second year, what we term part 2 of that particular program. In mechanical engineering, we offer a mechanical engineering degree and a mechatronics engineering degree, and we're about to change the name of the department. So at the next University Senate meeting, we'll be seeking permission to change the name of the department from mechanical engineering to mechanical and mechatronics engineering. And the reason is that over time we've seen a change in the balance between those 2 programs. So they're about equal now, but with mechatronics growing quite steadily. Chemical materials engineering offers 1 specialisation in chemical and materials engineering. Electrical, computer and software engineering offers 3 specialisations, 1 in electrical and electronic engineering, 1 in computer systems engineering, and third is software engineering, and that is jointly taught with computer science, which is part of the Faculty of Science. And then the 5th department is engineering science. They offer 2 degrees, 1 in biomedical engineering and 1 in engineering science. So of those 10 specialisations, 9 are fully accredited under the Washington Accord. So that leads to global mobility of qualification. Students who complete a Washington Accord accredited qualification here can go and work in overseas in countries that are also signatories to that accord as though they've completed a qualification in that particular country. The 10th specialisation, structural engineering, we can't seek full accreditation until a cohort is actually completed, but later this year we'll be seeking provisional accreditation of that qualification. And our chemical and materials engineering program has dual accreditation. It's also accredited by the Institute of Chemical Engineers in the UK. Now, as you've seen, or those of you who went on the tour have seen, we've recently opened a wonderful new building here, which has been purpose-designed to transform our teaching to a more active, engaging style, one which encourages innovation and leadership. We want to move away from the traditional lecturing that I'm doing now, saved on the stage, to much more guide on the side, where we're getting students involved in active, authentic activities which are drilling into the key, difficult threshold concepts that occur in all of our disciplines. So they're spending time on the learning obstacles rather than us wasting their time, giving them information that they could actually find themselves on the internet. So that's our aim. Of the 11-storey building that you're in at present, the first 5 floors, levels 1 to 5, are teaching and a general space, whereas floor 6 to 11, including floor 8 that many of you went out to earlier, they are our research spaces. So a particular design feature of this building is we've introduced 26 flexible learning spaces. We call them multidisciplinary learning spaces, or MDLs for short, but but they are the environments where we hope to transform our teaching, to move from sort of didactic lecturing to a much more engaging, active style. And in addition to that, the new building also includes 50 research labs, some of which you would have seen on the tour earlier. Now, quite apart from the city campus, as most of you will know, we also have an engineering presence on the Newmarket campus, and that houses our physically large laboratories. So in a central business district site like this, we just can't afford the space that's needed for very large laboratories. So out of Newmarket, we have our structures test hall, our fluid mechanics lab, the wind tunnel, our composites research lab, and our additive manufacturing lab. And as most of you will know, the Newmarket campus also houses our industry-facing activities and our industrial co-locators. So returning to research, we've conducted a very broad range of research from fundamental to applied, but particularly encourage projects that have a visible positive impact on communities. So you've seen some this evening, but other examples that you won't have seen this evening are work on inductive power transfer, particularly for vehicle charging, earthquake and structural engineering, geothermal engineering. You've possibly seen some of our medical and healthcare technologies in terms of the robots. We've engaged in yacht research, and perhaps our most recent activity is space. So on this floor, actually behind where I'm sitting at the moment, we're developing a mission operations and control centre to be used for the methane sat project. So that's for a satellite that's soon to be launched to measure methane emissions, obviously with climate change is the sort of setting for that particular research. So for anyone who's not already connected with us, someone who needs a pathway to engage with the university to discuss opportunities or particular technical challenges with the faculty, a couple of friendly and helpful options would be the Newmarket Innovation Precinct, the NIP, or the New Zealand Product Accelerator. So I just asked Claire and Hushpreet just to stand, identify yourself in case anyone doesn't. So Claire looks after the NIP, Hushpreet. Masood, of course, is a member of the NIP, and it was through that membership that TechTalk and the IMS projects and partnership got underway. So Masood, the faculty is very supportive of that initiative, of your passion, and the TechTalk mission to grow closer ties between tertiary institutions, between industry and students, with the aim of boosting the STEM sector, to provide better opportunities for all. So with those few remarks, I welcome you all again to the University of Auckland, to the Faculty of Engineering, and I'm very much looking forward to hearing from our speakers this evening. Welcome all.
There we go. Thank you for that. So for our competing audience, can we give another round of applause? This time I want to make it nice and loud so they can hear us. Yeah? Let's see if we can out-compete them on friendliness. Cool. Okay, so we've got 4 speakers. It's going to go quick tonight. We're slightly behind schedule, but I think we can speed up. Richard Senior, Carol Buka, Dr. Jan Bolsa, and Dr. Mehdi Shahbazour. Did I pronounce that right? I've been getting coached. Awesome. Ladies and gents, our first speaker tonight is Richard Senior, Chief Technology Officer and founder of Rothos. Am I pronouncing that right? It'll do. It'll do for that? Yeah. All right, thank you, sir. A short biography. Short biography. Richard inspires the innovation and technical vision for the Rothos platform, as well as leading the development team. As a global expert, the acoustics I could get that. As a global expert in building high availability cloud software platforms that have millions of device connections, Richard has a personal passion for robotics and the difference that they can make. He has managed the development of cloud solutions for the likes of Fortune 500s, including Visa, whilst based in London. Richard moved to Aotearoa to be head of engineering at Berkshire. Amazing. Can we give a massive round of applause?
I'll try and work on the technology.
Yes, I know. You're at the virtual station.
Yeah.
And our live stream is coming from here. Do you want to enable the cameras?
Yeah, we just see what's going on.
While we're getting set up, that's the beauty of being hosted by different locations, is that we've got to make it work. It's a good test of our adaptability, right? So thank you for helping us make it work tonight. There it is.
Thanks for having me on. It's great to be here. Particularly looking forward to feedback. Particularly looking forward to the other speakers after me. I can just relax after this, which is quite nice. My talk is going to be very robot-centric. That's thanks to what robots does, which is it's really trying to solve the problem that the industry has right now with adoption of robotics. So there's been amazing research for many decades now into robotics and electronics generally. And one of the issues, though, is that the uptake in the enterprise is still quite low. And one of the reasons for that is because making the jump and having something that works in the lab and works productively, effectively, reliably in business or the enterprise or industry, it's still a bridge that needs to be crossed. And robots provide a platform that helps bridge that gap by providing a way to allow customers to integrate fleets of robots, the things they do, into their business processes. I'm going to start by going, we are out the door and we've got major robotics. And this next video I'm going to show just outlines some of the customers that we work with, some of our partners, and just gives us a little sense of inspiration for where robotics is today.
What are the slides?
There's some amazing robots in there. There's different form factors. There's submarines surveying the ocean floor. There's boats doing hydrography. There are fixed arms helping people pack boxes. There's autonomous trucks doing container yard administration where they can move shipping containers around in yards, sort of 4,000 shipping containers, back them up to warehouses completely autonomously, no human intervention. But at the end there, you saw quite a big few seconds of that video dedicated to Boston Dynamics Spot, who are a development partner of ours. We've had them since around April last year. We took delivery of a couple of spots. One's down country doing some making a living. The other one, though, I meant to bring here tonight, and I'd always planned to. But sadly, I have to tell a little story about why Spot's not here. So just quickly, a little bit of Spot's holiday snacks, because we really wanted Spot to have a full Kiwi experience. This is Spot, Kiwi fruit orchards. This is where Spot famous in New Zealand, standing next to some sheep and being accused of being a sheep herding dog. This is Spot. Unfortunately, though, when Spot tried his hand at rugby, he popped an ACL and can't operate real league before. You can see this little bandage here, robotics characteristic bandage with a little hesitate. So got Spot's being shipped off to get repaired back in Boston before we get back. Having said all that, I want you to meet Stretch. Stretch is behind me, pretending to be a coat rack. This is actually one of my favourite robots because it's diminutive. an industrial machine, whereas this is more like a cobot. This is something which can do scanning of arbitrary shelves in warehouse facilities. It can do things like go up and down lanes inside big data centers, checking that there's no red lights that they need to attend to, which, believe it or not, still I think even in the most advanced data centers, there's still a manual inspection task required for humans to walk up and down and do the most boring job you can imagine, looking for faults and hardware. So they're looking at ways to automate that, and Stretch is a great form factor for those sorts of applications. For us in robots, we see nice soundtrack. So this is our interface, this is our 3D operations view. So this is Stretch moving on the right. Telemetry from Stretch is being bound to 3D representation on the left, which is one of the things that we do to provide context to operators working with robots in the field. So I just wanted to present Stretch. It's a lovely little robot, probably a little bit, what's the word? He's a bit slow, but he also gets teased a bit compared to the sort of dog form factor, which is all amazing cool. And I really like Stretch. But we're here today a bit more grand than this robot. Probably see it in we're going to talk about automation primarily. Why are we talking about that? And what's the theme? How does that relate to the theme of this whole talk? Well, this is why I probably summed it up. Apparently, the positive probability of automation will generate up to $2 trillion for the Australian economy. If they're wrong, by half, that's still a heap of value that the concept of automation is providing to the industry. When we I want to show you the actual example of a mission being executed for a business, and we can talk a bit more about the technology that underpins it. It's Tech Week after all, not Business Week, and go from there as what we think the future of industry for robots like. Before I do that, I'll talk about digital transformation, which is how companies today understand the requirement for physical automation. So for decades now, people have been working on digital transformation. They've been doing all these things, desktop automation, business process automation, robotic process automation. It's a bummer they use robot because it's not. But automating business process digitally has seen a huge amount of investment and a huge amount of money created. Above that, you've got machine learning decision engines, which start to really extend the physical automation concept. So where we see digital transformation is starting to land in the world of physical automation. You imagine that the most sophisticated sensor platforms available today, so robots, are really the interface between the physical and digital world. So even if your robot's sole purpose is just to collect data for a company, that is still a heap of value just there. We move on to how AI applies work, and you start to see this whole progression through industrial automation right through to where we are now, combining the world of digital with physical through robotics. And as the mission being executed to show a process being automated using a robot and that process is digital. This is our portal being used to execute the mission code. So this is the execute anywhere in the world using SOT to execute very specific valuable users. where's the technology, and how does technology play into this? And so these are what we call the automation fundamentals. These are things that we've built as part of our platform, but generally when we think about what you need to do to execute anything like this in a while with robots in an effective way, you have to think about these things. So connect, monitor, and control robots. And some primitive telemetry streamed off the robot. You need to be able to do that fast, effectively, anywhere in the world, over crazy internet connections, even with the best Wi-Fi network in the world. If you work in a container yard, those big containers like Faraday cables go behind it, network goes. How do you effectively get telemetry from the robots in a reliable way, which is consistent enough to then make operational decisions as you see it, but also to then execute some business logic based on what's coming off the robot. You need methods going the other way, so you need to be able to task the robot, tell it what to do, and generally control them. And you get to some really more stuff that you have to pull off. So in order to provide situational awareness for an operator, you need to be able to effectively stream what the robot can see. And how the robot interprets its world is often really, really heavyweight 3D point cloud data. And so this slide just talks about some of the challenges just with that. And David, who's in the audience over there, who heads up our R&D at Robots. This has been a baby for quite some time. I think the R&D got was some open source and a bunch of papers that you had to digest. But the outcome is that we can effectively stream point cloud data and have it show up in voxels in a weird interface from anywhere in the world. And it doesn't even more clever things like manipulates what the robot's sending based on the perspective of the camera in 3D space, so that it only sends what the user actually needs in order to get that uploaded evidence. Pretty full on. And later, I think, some of the talk stuff to me, we have talked about digital twins. This is a little glimpse of that, because once you can stream state condition monitoring data from a 3D environment into a model in the cloud or somewhere else, you start to build up this concept of a digital twin. So where does this all go? So at the bottom of the building blocks, which are the things I was just talking about, those are sort of Lego blocks or primitives, I suppose, pulling off any part of the operation like this. Above that, you get higher order stuff like teleoperation events, so you can do things reactively to stuff that's happening in the field of the robots. Spatial data streaming, as I was talking about. But above that is this whole concept of autonomy. You reel all this together. You have a visual interface for being able to create missions for robots. And through that, and an integration with AI and ML, as you start to be able to automate vast business processes using fleets of robots in the field effectively. So our vision, the thing that we, is one significant goal for us, is to be the autonomy platform for industry. We want to be able to orchestrate robotics across the enterprise. We want to bridge that gap between traditional industrial equipment, autonomous mobile robots, IoT, and AI and ML. One of the problems with productionizing AI is getting the data to the right place at the right time in order to make an effective decision at the right time. And so if you can thread all of these together, you start to get this really high order value proposition for industry. And when you think about the theme of this talk, which is about optimizing performance for business, for enterprise or industry, that's what we're really talking about. This is my last slide, but it's the one which I want to leave you with, which is if you take these three fundamentals that follow traditional industrial automation, so as an example, we've been working with people who make PLCs, running our agent on it, the thing that usually runs with a robot, so that we can integrate the operations of traditional mechanical industrial equipment with the world of mobile autonomous robots. If you can do that, if you can also bring the data from your IoT sensor networks, and industry just been through years of rolling out IoT sensor platforms, and the missing piece is the robot operations block. Put all that together with AI machine learning and an autonomy platform for industry which wraps it all together, you get extremely enhanced organizational performance. We're imagining our companies which can run entire physical automation automation processes automatically and make decisions themselves in real time to make the right decisions for the industry. That's all I have today.
When the speaker stays and just absorbs all the applause. Can we give Richard another round of applause? All right. If you're anything like me, I'm wondering, like, wow, it's almost like we're living in the future. Right? I wonder, to give our crew a bit of time to switch everything over, you would like to share what your biggest takeaway was from that with the person around. Preferably not someone that you've spoken to before. Go.
Yes, a clean switch over.
It's not, because I've just botched it somehow.
What's that?
I just botched the stream.
Epic.
Whoops. Okay, so for this one, we're going to have a PowerPoint. If you just want to tap as the slide goes, is that okay?
Those slides are in order.
If they're not, just keep tapping until you find it.
Okay, cool. Sounds good. I'll ask you all the questions I need to ask. I'll ask you like how you watch the stream, like how that happened, how to prevent it, and so on. We'll stop this. Wait, something's wrong with one of the mics. What's that? Can't really hear him, yeah. Okay, cool. So, now? Just press it once. Ah, sorry. Okay, cool. So, should I fade it? Yeah.
It's time for the break.
Cool, so
Right.
what do I do?
So our next speaker tonight is Hello Gupta, General Manager of Data and Digital Transformations at Spark New Zealand. I'm very happy tonight to hear from him. Hello has over 18 years experience in consulting, IT, leading technology and business transformation. He has a proven track record of developing IT and digital strategies, including the full cycle of digital transformation of Spark, New Zealand's largest telecommunications provider. So, ladies and gentlemen, can you please put your hands together?
All right.
Thank you, everyone. Hope you can hear me. This is great. It was a great presentation. Difficult to match that. So we are talking about. So there was. I was talking to Food on what the topics are. There's so much to talk about in terms of research, innovation. So I picked my favorite, which is around data. So I picked that because my role in Spark is I lead the data initiative in Spark. So I have data engineering, data science, and also what we call as realizing value for data. So those functions who are building use cases in Spark to deliver value. And I also have another part, which is the automation part, which is around developing automation solution, not the industrial ones, but the ones on robotic process automation, as well as using machine learning for automation. Now, I was an engineering faculty building, so I thought people will be interested in engineering, so I will start with that. Is that the basis of innovation on data is probably not in the data itself, because data existed for a long, long time, and AI models were there in 1950s or 60s. But what made the difference was the computational and the compression capability, which came with Moore's law, and I don't probably describe Moore's law to most of you, but it was around doubling the capacity of transistors in 18 to 24 months. For a business like us, which is telecom, there is another law, which is called the Cooper's law. And what the Cooper's law means, says, is that given a radio spectrum, the amount of data or voice transactions which will go through it doubles in 30 months. So in 2.5 years, we have one more generation of telecom capability which comes in. And these are generally given Gs, 2G, 3G, 4G, and now it's 5G. But I guess, as you see, the amount of data is increasing rapidly. And on the right-hand side, that's not the picture of an ET, but that's the picture of the quantum computing world. But there are quite a few in the market. But I guess the potential of that is it will continue to have the computing capability to fulfill the vision of digital and data transformation. And to do that, there is another thing to look at, which is as the computer power increases, so does data. And we engaged with Bell Labs and they were engaged to do a study with Spark to describe the potential of data, especially because we have to carry so much data through our networks, being Spark, which is a telecom company. And as you can see, there are points of inflection: browser, search, personal content, Napster. Probably quite a few weren't born when Napster was there in this room, but different discussion. Netflix, YouTube, the video world, and now we are in the sharing world of Amazons and Airbnbs. But the interesting part is the graph below, is the amount of data and the explosion of data which is happening. ZB stands for zettabytes, and a zettabyte is a million terabyte, a billion. So that's the scale, and that's the amount of data that is coming into the system for us to process. So that's why we need a solution to transport that amount of data. And we had 4G. Now what we are looking at is 5G, which is, the potential is that it will be around a lot faster than 4G and with low latency. So what does that mean in terms of use of that capability? So if we have a lot of data, we can transport it fast. So what does it give? Autonomous vehicles. All the school ads we see about vehicles running on their own, Teslas and other companies of the world. The management of that needs an telecom interface which can respond to that amount of data being transferred on the go. That's autonomous vehicle use case. Then in cloud gaming, how about we start our gaming journey at home and walk into a transport and nothing changes. So that's the amount of power of the interface or the network which is needed to give some of these experiences to life. So the way it is structured is, on the top are the ones which require high latency and reliability. On the right are the speed and capacity ones. Middle is IoT, and that's probably a whole new area of devices interacting, using the connections and the data enabling those use cases. Our important use case is drone and connected robots, and how they connect with each other in an integrated way. 5G is one of the enablers. Then there is edge computing. There are use cases which are coming up in telehealth. For example, how do you engage in a telehandler capability where you have images which needs to be transported over the network so that the telehandler recommendations can be done. So there are various facets of 5G, but this will also create some use cases, which one of them is America's Cup. So on the right-hand side, what we see is what would be a normal experience in an America's Cup, where the Emirates team New Zealand will have a boat which will go with the main boat and try to gather data so that they can redesign or change the boat to make it go faster. But that's a very laborious process because you have to run with the boat, gather the data, then go back to shore, download it, analyze it, and make changes. What on the left hand side is essentially the capability of using 5G, get the live data stream, and why you need 5G is the amount of data is really high. Get the live data stream, process it, analyze it, and then make changes to the design. What it saves is the most precious commodity in the race, that is time. So you save the time to get ahead. So if we have, that was a use case of 5G using data. Now there are other use cases. Spark is very keen on two other sectors. One is health and another is IoT. Now on the left side, what I was looking at over the week, especially with all the situation over the world around COVID, is health and how some people are getting affected by COVID and some are. So there is probably some factor in our genes, and what if we had precision medicines for everyone in the planet to direct the medicine which will work? Now, that's a great concept. Human genome costed $10 million to map in 2007. Right now, the cost of mapping human genome, because of the advances of Moore's law, is less than $1,000. And in some cases, especially for cases where they are used for commercial purposes, for example, identifying some linkage with the genome sequence. So the potential of precision medicine is increasing. There are various safeguards around privacy on actual use of this capability to target medicine. There is a lot of work to be done, but there is a whole lot of potential on using the computational power to enhance our lives. On the right side is a case of agriculture, and the case of agriculture is with IoT. The devices can help to optimize the most crucial resource in the agricultural food chain, which is around nutrients, water, supply, things which are impacting the environment can essentially be optimized for maximizing productivity. So this comes to the higher problem of the world hunger problem, because the population of the world is increasing. The cultivated area is probably same. If you increase it, that has an environmental impact. So there has to be a solution which creates a capability to optimize and make more precise judgments in what we do with agriculture. Both are areas, IoT as well as health, as Spark is interested in. I'll describe what some of our journey is. But the third one is the people who are really made it big in terms of using precision machines to deliver value are Google and Amazons of the world. Their whole business model is based on it. And they got the data, they built great customer experiences, more people got on it, they got more data, and they got better. So this flywheel effect was like a virtuous cycle of better experiences, cost-effective solutions, as well as then that gets more data. and they keep on going there. So how does that relate to a company like Spark? Because we are not a Google, we are not an Amazon, we are not that big. And how we are in the cycle of innovation through data? Because unless we innovate, staying still isn't an option in this world anymore, because the world is changing so fast, you need to go with it. So this is what Spark has decided to do. So in the middle are 3-4 major bets Spark is picking for developing or investing in for a 3-year cycle. So we have a 3-year cycle started last year. We are in the mid-year, and the 3-4 major key capabilities are: one is automated smart network, which is the 5G capability, which we discussed some use cases. On top is a simple, intuitive customer experience. So how do you make the customer experience more intuitive and simple? But both are based on the fact that we have the data beneath it to understand the customers and also offer the right experiences, and also manage our networks in a way that it gives the right experience and we invest in the right parts of the network. Now, what it enables is our established businesses like wireless, broadband, cloud, but on the right side, it enables those IoT use cases of agriculture, it enables digital health, and also sports. I guess some of you, or most of you know about Spark Sports, and that data set beneath these capabilities enable those use cases to be delivered. So ultimately, the idea is that someday we will have the data which gives us competitive advantage and also enables to give us automation for the customer experiences, makes us to work, develop more capability network, and gives great insights for our customers. Now, this may be interesting for you is that the R&D spend provides great returns. So if you see the business case of putting money in innovation on R&D, and there is a report on who were the biggest spenders in 2018. They were Amazon, Alphabet, essentially Google, Sanderson, and Microsoft. And you know how this turned out in 2021. We may not be able to do as much. They are like billions. So I forgot the last figure. Amazon had like $20 billion of R&D investments. Huge scale. But we still need to, in our industry, right the balance between too little, which has no impact, or too much that we are not able to put cause, and it's not efficient or is wasted. And that's probably the key dilemma for industry right now, is how do you look at R&D and innovation as an asset, not as an expense. And that's the struggle many businesses have. With bets like 5G, using data, AI, it surfaces the capability, but in an ongoing way, it needs the engagement of the academia and the industry to come together to understand the potential of some of these use cases for it to be used in the corporate world. So that's, I think, and thank you for.
So Colin and I have a mutual friend over at Spark, Chris Tui. So I'd like to get a selfie with him, or with you, to send to him. Is that okay? A nice awkward selfie?
Awkward selfie.
Awkward selfie. Thank you very much. Can we give Colin another round of applause? Thank you very much. It's so fascinating. We've been following these trends for maybe 10, 15 years, different people around the room, and it's just staggering to see how quickly everything changes. need a little stretch break just to get our energy bounced. So can I invite you to rise up and have a chat with the person somewhere near you about what we've taken away from that talk.
I'm learning small e-commerce fund, and I consider my job so we started out learning more life to much consulting years ago. Last one. So I want to make it so small as possible.
Hit record when it starts.
Make sure it's going red.
Sounds good. I hope no one stepped on my laptop because like it was there for so long. Oh shit. Right now.
Thanks, guys. Take a seat when you're ready. Thanks, video. Video always reminds me of Visual Couple. Anyone heard of Visual Couple? Engineers. We're in the temple of engineering. Anyone heard of Visual Couple? No. String theory? Does that sound familiar? Yeah. Right, welcome back, everyone. Actually, I wonder if we could get a couple of shout-outs. What sort of things have been coming up in your reflections from tonight? What's some of the takeaways you've been sharing? Can I get one or two?
You have been doing a good job.
Doing a good job. You're still awake, so that's good. And did you have one?
Sure, universal basic income coming soon.
Universal basic income. I think we might watch an innovation curve.
That's what someone else about.
And if innovation goes up, I wonder what else that brings up. So pretty good. Right, that's everyone. So, tonight we are very privileged to hear our third speaker. We've got it all going on tonight. Dr. Jan Holzer is a senior lecturer for smart automation and is the industrial liaison at the University of Auckland with a strong focus on Industry 4.0. Hands up who remembers what the Industry 4.0 is. Alright, cool, we are in lecture theatre. You are awake, this is happening. Welcome back everyone, come on. So until his move to New Zealand, Jan was the head of downstream automation at UoA, a renowned institute of applied research closely connected to Germany's steel industry. Ladies and gentlemen, please put your hands together with Dr. Jan Holzer.
I'm pleased to see so many people here this evening interested in new technologies. My question is about new technologies, especially to retrofit existing production plants. That's something we need in Germany, but even more here in New Zealand. I know there are fancy solutions out there from Bosch, Siemens, ABB. However, a lot of New Zealand companies aren't for that. So I would like to show you today two examples how a technology can be used to improve productivity. Keyword is digital twins. It's a technology related to Industry 4.0. So first of all, I want to show you what is a digital twin and show you two applications. one from Germany in steel mill, the other one here from New Zealand for wood processing. However, the concepts are not fixed to these production sites. It's quite a flexible approach. I just use these examples to make it a bit more tangible. What is it and how is the concept of decentralized production planning and optimization working? Here, I would like to distinguish what is a digital shadow. This is more or less state of the art to store all your process information in a database in time series. So that's good. The digital twin has also access to this data, but is doing something more. And we talk today what this more is. So we've got access to all this data, we've got access to models, and you may say, oh, we're doing simulation and modeling since decades. That's true, and me too. The new thing about the digital twin is that it connects real-time sensor data about your production plant, your product, and that makes your models, your simulation alive, and then we call it a digital twin. When it represents something, a physical asset in the real world, in real time, fed by sensor data. Then we distinguish between a simulation model and a digital twin. So, how do we combine that, this agent technology, a well-proven approach of IT? An agent is a piece of software, it knows who it is, it's got a kind of identification, it's got some communication capabilities, it can communicate to other agents, it can receive messages, and within some limitations, it's got a reasonable understanding. That's more or less rule-based. It's not really intelligent, but it receives messages, it knows what to do, it's got some rules how to react on it, it can negotiate autonomously on markets between other agents, for example, and it's got access to its memory and its access to data, so we switch the passive digital to something active. And how does that look in a steel mill? You've got tons of data, for example, for flat products. You've got surface inspection data, all the defects. You've got thickness overlays. You've got flatness profiles. A lot of data is stored to your product along the length. Digital twins of production sites are more or less well established and state of the art. So there's a simulation model with live data of your machine. A digital twin of the product that's still under development a bit. First implementations are done. So we are simulating properties of the product. Why is that useful? For me, it's about the problem to improve production processes. So, and then I'm looking for the right technology to do that. However, in that case, they modernized the hot strip mill, German steel mill, and then the next processing station, the pickling line, became the bottleneck. So the manager of the pickling line called me, CEO is calling me all the time, I'm now really under pressure, I have to do something. So we made a brainstorming session together with their engineers. What would improve that process? How could that process work faster? We decided if we want to improve that process, just to, so that you're not familiar with that, during the hot rolling, you reheat a slab and roll it down to maybe 4 millimeters, and then it's heating that process at 650 degrees in a coil, and because the surface is so hot, there's a scale of kind of rust growing on that surface, which has to be removed before it can produce the thickness in the cold water. That's where it's coming into a pickling line. It's your acid tanks where you, in a continuous way, transport your strips through these acid tanks, and that scale is removed. So to improve that process, these coils should arrive warm instead of cold. Usually they are immediately cooled down to room temperature or outside temperature, very cold in winter in Germany. And then the acid tanks have got almost 90 degrees and it has to be reheated again. So that slows down the process. It would be faster if they arrived warm. But we decided, okay, to make that happen, we need some models, we need some decentralized optimization because it's hard to predict how the weather is and how the production will run in the week. So the centralized approach wasn't working properly. What we've done, we first had to solve a gap in tracking and tracing. I mentioned that already in the lab. Installed the camera, reading the number of the coil transported by the floor transportation, and now the timestamp when that coil will transport into the coil shower. That's the moment when our digital twin of that coil is born. The reason why we introduced that virtual copy of that is the coil itself is done. It can't do any communication and any optimization. So that digital twin starts in communication with the pickling line. There's also a digital twin running, and asking him, when are you going to process me? So also our models inside doing a calculation that in 18 hours I would like to process you. Our digital twin knows now, okay, at the moment I've got 650 degrees, and in 18 hours I would like to have maximum 80 degrees, close to that. It looks outside to the temperature sensor, we've got 10 degrees. So we're using these models to calculate what would be best for the cooling time and what, because remaining time at air is 10 degrees. So instead of the usual 8 hours, it may use only 5 hours of water cooling because there are 30 hours of air cooling afterwards, arriving perfectly in the right temperature. So here's a kind of paradigm change. Usually the machine. Yeah, they are.
One is for the audio for the live stream, so it's not interfering with the other one. Yeah. Yeah.
So the paradigm is that usually the machine knows best how to process that piece that is arriving. And now we've got a virtual copy of that product, telling the fine-tuning to the machine. So that virtual digital twin is telling the coil shop, put me in a row, we get only 5 hour water cooling instead of the standard 8 hours. The effect is the coil arrives warm, and again, we know the temperature. And again, the cold coil will process slower. So now the digital twin is telling the picking line. Here in the beginning, I've got maybe 75 degrees. That means you can process me maybe 20 minutes per meter faster. In the middle, even a little bit more. In the end, a little bit less. So again, the digital twin is telling the fine-tuning to the machine. And models, the temperature model for the cooling with water and the air. We've got another model modeling the scale growth because it's quite a deciding part if it's taking 20 minutes or 60 minutes before the coil shower starts. And again, that this model tells the pickling line, is it hard to pick, is there a lot of scale on the surface or not? Information which haven't been available to the operator before. And these are the effects. What does it mean for production? First of all, we implemented that, and we see in the top graph the change of the temperature. The black lines are the normal temperatures of the coils, and the red lines are the coils produced with the new regime. And the effect has been that we've been able to produce these products 16% faster, when the other steel grade even 20% faster. And that by itself is a big number, but it's even more impressive if you think we haven't changed the picking process itself at all. We just took care that the material arrives in a more suitable condition to the same process. These have been kind of expected or hoped effects. For sure you save a lot of energy because the coil with 12 tons doesn't have to be heated up from maybe 0 degree outside temperature to 90 degrees and it arrives to 80 degrees. But there have been also unexpected positive effects. Steel, which is 80 degrees warm, is much smoother. They have some nasty sealers which tend to break if they've got damages in the edges. And they've got a particle surface inspection system in the end. And detected, oh, we've got severe damages in the edges, but the strip doesn't break, didn't break. Meaning with every avoided strip break, you get 3 to 4 hours production time for free. And that is a kind of unexpected success of the process, which makes us quite effective. Okay, let's jump to New Zealand. We applied the same process and product idea to wood cutting. It's a final good product running last year. Right now it's from Lizzie and Yvette. So SQL uses 2 digital twin approaches, one for the product itself, and so they measure the log in 3D. They've got a lot of customized wood cutting, so all these models have got different dimensions. The question is how to place these models best in the existing raw material. So that's the digital twin approach for that. And they've got a digital twin for the sawing line. The process is you're cutting your boards, they have got all different dimensions, and now you have to sort them. Because you have to deliver stacks of certain dimensions, but from one log you get like 8 different boards in different dimensions. So they have got a sorting process, and that means you've got 80 bins. And until up to now there was a manual decision which bin has to be sent to the stacker afterwards. And it happened quite often that the whole process had to stop if the bins are full, because if you can't put anything to that sawing line, you have to stop sawing boards. So the idea is we develop a digital twin, and for that second process, it's a robot. So we've got now a digital twin of the process, receiving the information of the product, what is coming, so it's looking into the future, what are the boards running in the next hours, having models for the second process, how long will it take, and is able now to make the decisions with district optimization, which sequence of emptying these bins would be the most efficient one. Something which a very good operator with a lot of experience also can do. If it's not that experienced, the efficiency is not that high. So the computer model has the ability to analyze much more configuration possibilities than the human brain usually is capable to do. And so we simulated and estimated some how big is the potential to improve that. And we saw one situation, the last line, where you see the emptying sequence, what the operators did, and the result has been 10 minutes downtime. And we suggested, okay, if you would have used the other emptying sequence which you see in the middle, you would have avoided that downtime totally. So the estimation is that if they implement that, there's a chance that they will increase revenue by 2.4%, meaning maybe $1 million per year. So that has been quite successful, and they're doing the on-set integration right now. The Hayat Lizzie is now there at SQL, and I've got further projects with SQL together. So this is just one example what the outcome of a 5 million project with our university could be. Okay, that's from my side. Thanks a lot for your attention.
Thank you very much, Tommy. There we go. Excellent, thank you. I hope you're enjoying that so far. We have our next speaker coming up tonight. He's actually been with us for a very long time and is a massive supporter to the TechTalk conversation. It's Dr. Mehdi, we get this right, Shahbazpur. Yeah? There we go, Mehdi Shahbazpur. I'm waiting for the approving nod to say that. I did a good job of pronouncing that.
Yep.
There it is. But IMS project partnered with TechTalk a while ago and is really shaping the conversation for what happens next. And Dr. Shahbazpur plays a key role in IMS project. Is that right, Andrew? Oh, hell yeah.
No recording.
Corroborated. So,
We're putting it back up.
a little bit about Mehdi. He has led innovation management in many New Zealand businesses, including, or most notably, Future Building. He is an experienced facilitator and a hands-on coach with in-depth experience and knowledge about what it takes to build innovation management capability and culture in an organisation. Pretty soon I'm sure he's going to take my
Why do you think it's going to be this?
For TechTalk, I hope. No? Very good son. Ladies and gentlemen, please put a very warm welcome and a hands together for Dr. Mehdi.
Checking the audio, you can hear me? No? This one? Yeah. So this is one.
That's for live stream. Yeah. You got it.
All right. Thank you very much. I know I stand between you and probably home for more conversation, so I'll try to make this quick. Richard set me up so far I talk up really well when he talked about the fact that this is tech week, not business week. So, unfortunately, he planned to talk about the business side of what I do, but also he showed robots. So I hope I can quickly go through my slides, share with you my insights about the management side of R&D. And more importantly, probably from what Richard and the other speakers showed to us tonight, is that technology is well advanced. It's probably beyond our imagination of what is possible. So we're not limited by our imagination anymore. And I can speak on behalf of the businesses I have worked with and worked for, that the businesses get the point, that they see the value in all of this. Yet, we remain not fully engaging with these type of technologies as much as you like, right? We're still experimenting, we're still a bit shy to get there. And I think it has a lot to do with what I want to share with you guys tonight. It's about organizations building the capacity to introduce these types of technologies while still running their ship, while still running their businesses. And that's a big challenge. And that's an invitation from me and IMS that I work with is, and all of our clients that, that we need help in developing better technologies to get this side of the whole equation done well as well. I want to start with a show of hands. How many of you guys believe in this statement? Innovate or perish? No? Some non-believers, they don't believe that, either innovate or perish. Most of the people here make a case, at least the technology people, that we should be innovating, and otherwise that we're going to be left behind. Most of the CEOs that have been surveyed around the world, corporates, small businesses, startups, talk about the fact that disruption is a lot more real than what they imagined before. That all of these amazing technologies create emotions of fear and anxiety in some of us when we see them, all those robots rising up and doing the human stuff. These are real. They're actually not in science fiction anymore. They're in here. Companies like Rocos is making it happen, and so it's really at our doorsteps. So, innovate or perish is a reality. Many people believe in it. But I also think there's a lot of innovate but still perish. Lots of companies attempt to innovate, but still don't end up innovating on the right areas. No one thinks that Kodak, for example, was not innovative. No one thinks that the people who made typewriters were not innovative. They were innovating in their own domains, but they were probably not innovating in the right areas or in the right ways. And Blockbuster was innovating. They probably had a lot of R&D and innovation in the pipeline, but it's still they were perished. So there's also innovation and perish. So innovation can cause a demise of organizations if you put all of your resources in solving problems that people don't have, in areas of technology that that people don't really want a solution for, you could actually end up developing technologies and making big plans and taking on investments and yet still perish. Many startups don't end up surviving, even though they're working on a lot of cool technologies, they're innovating, they're attracting a lot of investment, but yet still they don't survive. Segway was a company that many of you guys are probably familiar with, that that thought that they're going to change the world with the technology they had, and eventually, what was it? How many did they plan to sell, Adrian?
Yeah, they said one time bigger than the internet.
Yeah, they were going to be bigger than the internet, but they weren't. Segway. I think you still haven't heard of it. They were going to be bigger than the internet. And the guy who bought the company apparently died going off a cliff on a Segway. So, the proposition is that companies need to innovate the right way, or they will perish. Right? So there's innovation just for the sake of innovation, technology just for the sake of innovation. Technology is not necessarily going to add the value that you need in order to survive and prosper as a business. At IMS, this is what we're trying to do. This is a bit of a plug, but we help companies of all sizes and forms to craft and implement their right way, because it's not one right way of innovation management. Every company needs to develop their own way. They are unique in the way they operate, they manage, they have a history that makes a big impact on how decisions are made what areas of knowledge they're exposed to, and also what their areas of knowledge they're comfortable taking in. As a result, it's really, really important that you find the right way for you. And that makes it even more complex. So the question I have is, and this is what we have been thinking about and have been working on in some capacity, is how we use data and technology to innovate the right way. Innovation at its core is quite simple. You form an idea, you put a team together, you get some of these amazing technologists to help you, and you get some results. Yeah? Yeah? Yes. But it's a lot, in doing so, it's actually a lot more complex than that, right? First of all, you don't start off with an idea. You start off with a mess cloud. The best description I could find for it was probably a cloud, a fog of mix of things. Ideas, some sparks of ideas, not fully formed ideas. You start off also with some questions, problems. You start off with some knowledge that you have in people's heads. You start off with technologies, cool stuff you've seen on LinkedIn, in TechTalk, which kind of makes things plausible in your head. Oh, we should really try to do that. We should really talk to the guys who do all those robots and see how we can use those. So all of those things start to bubble. And they're not formed in a very structured way. And I'm not sure if you can see the slide, but we need technology to help us capture this. We need technology to help us relate these things, these concepts, these constructs. We need to structure them, because otherwise they will not be in use to us. We need to categorize them, combine them, search through them, assess them, discuss them, feedback, rank them, so that then we can form ideas. And we need technology to help us do that better. The danger is, if we don't do this well, you could actually end up spending a lot of time and energy, with a lot of excitement and engagement within your companies and people in that space, and it goes nowhere. The mess just gets bigger, the cloud gets bigger and bigger, it involves, probably gets a lot more sophisticated, has a lot of technologies and thinking in there. You might do, what do you call them, hackathons and stuff like that, and engage with universities, and just stay in that space for a long time, and not really venture into ideas that you take on and do something with. And this is where a lot of the research shows that 80–90% of projects, ideas, stop at the pilot stage. They experiment in this space, but because it's such a fuzzy space, it stays there. It doesn't proceed to any real eventual change inside companies. The challenge also is that you don't end up with one idea, you end up with lots of ideas. And your team probably has some of their own ideas that they've been working through. So you need, once again, technology to help you sort through these ideas. You need to do more than just sorting. You probably need to help defining them, refining them, getting them ready for the project team to start taking action, taking those ideas which are at their essence possibilities, and making them into something that is actionable and delivers value. And once again, we need technology to help in this space. Capture, define, relate, categorize, evaluate, estimate, help businesses put a dollar value with confidence against these ideas. We have $2 trillion of potential there. We need better technologies of estimating the value of these projects. Once you have that idea, you put a team together, you go through lots of iterative processes. If you follow latest innovation processes and thinking, you do this iteratively, you learn from your insightful, you apply things, you learn from that. You don't just try to answer the technical questions, you also try to answer the customer questions, and you do all of that in the project team while trying to capture this information and be able to make sense of it so that you can make decisions and move the project forward. Eventually, you're going to end up with some sort of value proposition, some sort of product or a service, something that you have actually developed that you can sell and market. And during the whole process, you're generating knowledge, right? You're generating knowledge about the product, you're generating knowledge about technology, you're generating knowledge about customers. And all of these, once again, need to be captured. They need to be captured and preserved and fed back to that messy cloud at the beginning so you can restart the process again. Once again, we need technology to help us there. Finally, the ideas need a business model, need to be linked back to the overall supply chain, value chain of the business, pushed out to customers. Then you start learning again. If you're doing any of this smart stuff with your products, you start getting data from your customers about the use of their product. That, once again, needs to be captured and fed back. You have to assess the performance of these ventures you have created, these new products you have launched, so you can actually feed that back, that information about and enhance your ability to estimate future value of those products or services or technologies you've implemented. And once again, all of these can be done better with technology. Now, to add probably 10 times more complexity to this process that seems quite complex is the fact that this process exists in an existing company. An existing company that is not there to do this, but is there to do all the other things they do. A business as usual. They're there to make products and services, satisfy customers, produce goods, distribute stuff, develop code, all of those things at a company that they do on a normal day-to-day basis. The resources, the creativity, the ideas, and even the money for all of that bottom layer has to come from the top layer. And I don't know many businesses who have a lot of slack resources. Maybe Amazon and Google do, but in New Zealand, majority of our businesses are running quite lean. They're operating in global markets, very competitive. Obviously, with challenges of the current situation with the world, they're probably even leaner than what they have been before. So somehow, the managers of those companies, the executives, have to find money, resource, time, capacity, technology to make the bottom part of this going, to engage with the robot companies, to come and work with universities, to do all of those things while the top part survives, not just survives but probably prospers because they have shareholders to report to. And that makes it even more challenging. That's because the best people who can work on the projects at the bottom are the busiest people who are working in the business at the top. Once again, not by the imagination, by the value, by realization of the technology, but actually limited by capacity to even think about some of the stuff at the bottom. Even so, for that top layer as well, that business as usual, there needs to be some governance of the bottom layer. And that governance typically looks at making sure they're doing the right mix of projects, making sure that they're managing and retiring risk, making sure that they have the right type of processes, established routines and processes for managing the bottom processes, making sure they're managing capacity. This capacity is, at the end of the day, going to make or break the normal business or the innovation project at the bottom. So a lot of times, if you innovate, then perish, you are not making those things in the right order. And so technology can help by consolidate, produce reports, and put the right information in the hands of the decision makers at the board or innovation steering groups, so they can make the right to the question, how might we use data and technology to innovate the right way? I would love to give you the answer. I don't have the answer. I will make an attempt to give you the answer in the MADE conference. I said I'm going to make a shout out to the MADE conference. There's a little leaflet in front of you. I will present a data model in that conference that tries to make sense out of all this stuff. But in the meantime, at IMS we've been experimenting. We've been trying different tools, and mainly around Microsoft set of tools. We've been making dashboards for board meetings, we've been doing technology road mapping, we've been making Excel tools that help project managers track knowledge as well as manage the level of risk that's in the business. We've also been experimenting with the Microsoft Power Apps, making apps that help this whole process better. We haven't cracked it, but we think we're thinking along the right stuff. And once again, an invitation to you all, if you want to collaborate and experiment with us, please contact me, Adrian, or Nick, and send us an email at hello@OMS Projects. Thank you very much.
Give me another massive round of applause. Thank you very much. Oh, so many good things tonight. One of the quotes that came to mind for me was, whilst change is constant, progress is not. You're feeling it? You're feeling it? So ladies and gents, that's the 4 speakers for tonight. How cool was that? Yeah. Yeah? Awesome. Thank you very much for staying with us through all that. We're going to go into kind of wrap up mode now. Oh yeah, thank you for flicking that over. Can I invite Adrian to come up to the stage? Adrian's from IMS Projects, one of our key partners. Can you give him a round of applause? Thank you very much, please. And we're going to dish out some of the old thank yous. So we'll give you one of those. Is that yes. So we had Claire pop down to come and receive a little token of our appreciation. Ladies and gents, Claire has been the force majeure behind the scenes. Jan also down as well. Thank you, Jan. Massive round of applause for that. Awesome. Yeah. We're going to get that. We'll get the old cheesy politician strut. Here it is. And Dr. Mehdi. And apparently your name is a king and son.
Yes.
Is that right? Is that the same as Prince?
Almost.
Almost. Thank you very much. Round of applause for Vicky. Richard Steen. Thank you, my friend. For bringing us the program. And we're going to make sure that Carl Gupta gets his token of appreciation as well. But can we give him a massive round of applause? Oh, excellent.
So,
thank
one
you.
of the things I want to say, my name is also Claire. So, Dr. Jan Fulter, who spoke earlier this evening, just to let you know, we also host at the New Market campus Tuesday forums, which are not technical.
massive round of applause and a thank you for our partners, TechTalk partners. Boom,
So
we're at the wrap-up
when
stage.
he wraps up and talks to
And committee members and volunteers, without them, none of this would work. So we've got technology herders in the background to make it all work. Thank you very much. And all the amazing technical volunteers that have supported the event. And actually, how about you guys? A big round of applause for all of you. Thank you. One last housekeeping plea. Could you grab your smartphones? And while you're thinking about the whole night and the things that you're going to share with somebody in a moment about your key takeaways, take a little camera phone thingy at the screen and fill in our survey. It's 6 easy questions. They're literally tick boxes. Take a moment and do that, and that'll feed into our data view for you for the next time. It's completely anonymous.
Yes, it is not work because you are very far. So you are on this very simple stairway.techtalk.
Here we go. Cool. And don't forget, right now we're going to be doing our massive group photo, which we're going to get everyone to come down to the stage, take off the background, and photographer is going to do his thing. Right, team. We're almost there. Follow us on social, come rise up. Grab someone you haven't spoken to, and on your way down, share one of your biggest takeaways tonight. Thank you very much for coming along. We do a group photo and we can catch up.
Alright, I've done the server shout out on the live stream, so that should be everything we need. That's very media. That's cool, right? That's cool. Can I connect with you on LinkedIn real quick? Yeah, sure.
Thanks for sticking around.
Yeah, always well. Yep. Stop. Check. We have none so far. Not yet.
How many live viewers have we had?
It varies across the night. I can't remember. So.
Right, team, let's come on down. And everyone just relax yourself at home.
First name's Italian, last name's Dutch. Yeah. Starts a lot of conversations.